morning, Stats fans. How we doing on this fine Wednesday morning? Yes, it is a Wednesday morning. We continue to lose track of what day it is, but it's Wednesday. A little cloudy, a little sunny, calling for a little bit of rain, but they're calling for some warm weather today and tomorrow. So hopefully we can keep the warm weather and also this weekend being nice this weekend. We're going to continue. I hope everything's going well with you in your house. Hope everybody's staying illness free. We're going to continue with the z-testing today, and we're going to actually do some z-tests. We're going to actually do some mathematical things in regards to testing of the hypothesis. Now, what we've talked about the last couple days is we've talked about hypothesis, a null and alternate hypothesis. We talked about left tail test, one tail test, and two tail test, left tail test, right tail test. We've talked about all these different things. Now we're going to start applying all these things. The other thing we talked about yesterday was the idea if we're going to have a test value, and if that test value falls into a critical range, we're going to reject a null hypothesis. If it's a non-critical range, we will fail to reject a null hypothesis. Well, what connects critical to non-critical is there is a critical value. There's a critical value for a z-value or a t-value that we'll eventually use that we will utilize to be able to separate our regions from critical to non-critical or non-critical to critical regions. Now, these values here are the critical values. When we talk about an alpha value, and that's what will be given to you on a problem. An alpha value, which is a level of significance. A level of significance, that is this alpha value. Those will be given to you, which relates right back to a confidence interval, okay, because they are connected together. And our critical values that we have are these values that exist right here. Now, we don't have to memorize these critical values because if you pull out your t-table, okay, if you have to pause it, that's fine. Pause it. Pull out your t-table and look at your t-table. On the top of your t-table, what we dealt with at the top of your t-table was the first one was the confidence interval. Okay, this confidence intervals, we talked about 50, 80, 90, 95, 98, 90%. That was what we talked about so far. But if we look at the next two lines here, right below the confidence interval, what you see is a one-tail test and a two-tail test. A one and a two-tail test. You also see the values at the top that go across the top. These are your alpha values. And these alpha values will be given to you within the problem. Where if I had a one-tail test, here, with an alpha value of 0.10. I go to one tail, an alpha value of 0.10, which is the second column, and I take it all the way down to the bottom. We have a value of 1.282, which is this value right here. So these are your critical values. But you can get that along with the t-table, and this t-table is an awesome table. This is probably one of the more important tables that you have that you can utilize with the normal distribution is this t-table, because you can get so much stuff from just this t-table. If I had a two-tail test with an alpha value of 0.10, well, I go along the two-tail line to my 0.10 and take that all the way down the bottom, and I get 1.645. which is my critical value here. So you're going to be utilizing this t-table quite a bit when you're trying to find our critical values. Now what we will be doing is we will be calculating a test value. And how we calculate this test value, the z-test value to test a hypothesis should look very similar. Okay, x bar minus mu divided by standard deviation divided by square root of n, which is our central limit theorem. we've calculated our z value already with this stuff. Okay, it's not going to change. We're going to do the exact same thing. X bar minus mu, standard deviation divided by square root of n. This is going to be our test value. If your z-score falls into a critical region, you will reject a null hypothesis. If your z-score falls into a non-critical region, you're going to fail to reject the null hypothesis. Once again, you may not quite agree with it still, but you don't have enough data, enough information to reject it. So you just fail to reject. You don't accept, you fail to reject at that point. So two situations will occur: you reject or you fail to reject. So what this looks like, if we look at a two-tailed test. A two-tailed test. Okay, we have two tails here. We're going to get critical values. Once again, two tails means you're going to get two tails here. These are going to be your critical values. And the critical values, once again, it depends on the alpha value. If it's an alpha value 0.01, 0.05, whatever the critical values are. And then you're going to get a test value. Oh, I'm sorry, critical. We got the critical values there. This is a non-critical region. This is a critical region. And this is critical over here. We're going to take a test value. And if this test value falls in a non-critical region, we fail to reject the null hypothesis. If your test value falls in a critical region, we will reject the null hypothesis. Okay, so here we reject. This is a fail to reject. And we guide, what's going to guide us, once again, is these critical values that we can get from our table. These are our critical values, and then our test value here. So our critical values and our test values are going to guide us through the problems. And if this was just a one-tailed test, now if it's left or right, it does not matter. What happens with a one-tailed test is we only have, this would be a right tail. Because I'm on the right side of the graph, so that's going to be a right tail test. And remember, when I have a right tail test, that means my alternate hypothesis is going to have greater than a value. This is going to be non-critical, and this is going to be critical. And this will be your critical value right here. And once again, you pull your critical value from what we did up above, or once again, your t-table will give us our critical value. Okay, so we look for our test. If our z-test occurs here, we fail to reject. If my z-test occurs here, I reject the null hypothesis. Steps for solving hypothesis testing. We state the hypothesis, and identify the claim. Sometimes you have to identify the claim. You know, I'll sometimes state it, sometimes I won't. We just need to get the null and null hypothesis down there. Find your critical values. And with these critical values, what you should do also with this is draw bell-shaped curve. Sort of like what we did up here. Draw your bell-shaped curve, find your critical values, put your critical values in. Next thing we're going to do is compute the z-value, the test value, which is x bar minus mu divided by standard deviation divided by square root of n. Once again, this does not change. X bar minus mu, standard deviation divided by square root of n. Same way we did our central limit theorem. Okay, that's not going to change. Make a decision to reject or fail to reject a null hypothesis. So you're going to place this test value here. Where does it go? Do I reject or do I fail to reject the null hypothesis? And lastly, maybe, there we go, summarize the result. And summarizing, just like with the confidence interval, we do not have enough evidence this time to reject a null hypothesis of this mean being whatever, or we can reject the null hypothesis of the mean being this value. So we have enough evidence to reject it. So that will be your summary statement at that point. Let's take a look at a problem. A medical rehab foundation reports the average cost of rehab for stroke victims is $24,672. Random sample of 35 stroke victims had an average cost of $25,226 with a standard deviation of 3251, alpha value 0.01. Can it be concluded the average cost of stroke rehab at a particular hospital is different from the 24,672. Now that word different makes it a lot easier to be able to do our null and alternate hypothesis, because the other way would be is greater than, or is less than, or is different. When we have a different, that allows us to do a null and alternate hypothesis. Okay, when we have the different, we don't know if it's going to be greater than or less than. So what we have here is we have a two-tailed test. So we have mu not equal to the 24,672, which means over here mu will equal 24,672. Okay, they took a sample of 35 patients. Their average cost is $25,226. Their standard deviation was 3251. Now, we can use a sample standard deviation, that's fine, just so we use a standard deviation. And we have an alpha value of 0.01. Now, if we take a look, once again, we have equal to and not equal to, so this is a two-tailed test. So let's get our bell-shaped curve down. Oh, tartar sauce. We have a two-tailed test. So we're going to get critical values on both ends here. Once again, two tails here. So we look for our critical values, so now we go to our t-table. Go to our t-table. We have an alpha value of 0.01, so we go along a two-tail column, or two-tail row, to an alpha value of 0.01, not 10, 0.01, which means we go to the very end and drop that all the way down. So we get 2.576. And because of the symmetry idea, we have one that's going to be positive, one's going to be negative. The left side's going to be negative. This is critical, or this is non-critical. This is critical and critical. So we now do a z-test score, which is x bar minus mu divided by standard deviation, square root of n. So we have to calculate our test value. Our x bar is 25 to 26 minus, and once again, if I'm going too fast, just hit your pause button. 25 to 26 minus our mu, which is 24,672. Our standard deviation is 32.51 divided by a square root of 35. Now typically what I will do is I will do the top, find the value, and then divide by the quantity on the bottom. So let me get my calculator out here. I won't be able to see my numbers. So I get 25.26 minus 24,672. Hit enter, we get 554. And then I just divide at that point by the quantity of 3251 divided by second square root of 35. Pull out of the radical, and then my quantity. So we have 3251 square root of 35. I get 1.08. Or I'm sorry, 008. So my test value, here's my 0 in the middle. This is 2.576. Falls somewhere in that range right there, which is a non-critical region. So at that point, we fail to reject the null hypothesis of the average cost for stroke rehab equal to the 24,672. Now, I'm not very close over here to my value. If this value came down to like 2.5 or 2.48 or something like that, which would be very close out here, then I would fail to reject the null hypothesis, but I would probably go back and restudy it again. Maybe try a larger value or a larger sample size. But since I'm not very close to it, I fail to reject it. I'm probably not going to study it too much longer at that point. Maybe I'll wait for a year and then try it again. But I just fail to reject it, and that's fine. A study found the average stopping distance of a school bus traveling 50 miles per hour was 264 feet, which is like the length of a football field or close to it. A group of automotive engineers decided to conduct a study of 30 buses. Average stopping distance was 262.9. Standard deviation was 3 feet. Tesla claimed the average stopping distance of the company's buses is actually less than 264. Okay, now we have the key word less than. So we have the null hypothesis and the alternate. Once again, the key idea is to set your alternate hypothesis first. So we're going to have mu is going to be less than 264. Which means opposite to that would be mu would be greater than or equal to the 264. So looking at our values, let's see, we have mu is 264, we have n is equal to 30, their stopping distance was 262.9, their standard deviation was 3 feet, and we have an alpha value of 0.01 again. But now we take a look, we have less than and greater than. So is this a one tail or two tail? That's correct, it is a one tail. Now is it a one tail, is it left? Is it left or is it right? Well, it's going to be left because of this right here. Because this is pointing it towards the left-hand side. So if I look at my bell-shaped curve, draw my bell-shaped curve, this left side, this being left, tells me where I'm going to throw my critical value at. I'm going to throw my critical value on the left-hand side. So now we go to our t-table. Now we're going on the one tail line. Okay, so we go along the top here, a one tail line, alpha value of 0.01. It's not the last column anymore, it's the second to the last. And I'm going to drop that all the way down to the bottom, which is 2.326 is my critical value. Now, since I'm on this side of the curve, if I'm on this side of the curve, what do we have to remember to put with that? That's correct. We need to throw a negative in there. This is non-critical. This is critical. So we do our z-test now. X bar minus mu divided by standard deviation, square root of n. Our x bar is 262.9. Our mu is 264. Our standard deviation is a value of 3 divided by square root of 30. Once again, I tend to just do the top part first. Saves me having to put an extra set of parentheses in there. Minus 264. This comes down to negative 1.1. Then I'm going to divide that by my quantity of 3 divided by square root, oopsie. Let's see, negative 1.1 divided by quantity 3 divided by second square root of 30, pull out. And I get negative 2.008. Which throws me right here. I'm still in a non-critical region. So we fail to reject the null hypothesis of stopping distance equal to 264 feet. But since I'm pretty close to my value here, it may warrant me trying to do another study with that, maybe include more buses, or maybe doing do something a little bit different. So this here being so close to it, as a person that's doing the study, I might want to try to study it a little bit further. This is hypothesis testing. Now, what I want you to do, the worksheet we've been working on, with regard, I had you do the null and alternate hypothesis, then left tail, right tail test, or one tail, two tail. That's all you've done at this point. Now what I want you to do is go back and do the problems. I want you to do the actual hypothesis testing. So you follow the same process that we just did here, and now do your hypothesis testing at that point. We have one more thing that we're going to do with that worksheet. That will be tomorrow. It's called a p-value. Okay, that will be the last thing we do with that worksheet. Then at that point, I'll probably give you Friday off, and Monday we'll come in and we'll start doing some other material. We'll do a t-test. We do hypothesis testing with the t-test. We do hypothesis testing with the standard deviation, and then we do a set of 2 means, and we compare 2 means. And that will be the last of the material. So we are getting close to getting done with our material here. Okay, once again, my goal is to hopefully sort of wrap things up here at the beginning of May, prepare for the final, and get the final done at that point. Please keep up with the material. Please keep up with the material. As we go through this, please keep up with the material so we're not trying to chase things around at the very end. Check progress book to make sure I have everything in progress book that you've handed in. I think I've got everything, but I still may have missed something. What I've graded, I put into progress book. Please check to make sure that you've done that. If you've done it, either resend it or just send me a message saying I've done it already. Please check on Google Classroom or check your emails. So please do check that. Other than that, I have nothing else for you at this point. Tomorrow we'll come in, we'll go through one other value with respect to a p-value. We'll do calculations with a p-value at that point. Other than that, I miss you guys, wish you were in class, but it's our reality, that's fine. We'll go, there's always plan B's in life, and this is our plan B right now. We'll get through what we need to get through here. And once again, please do keep up with the material. You've done a nice job up till now. You've been doing well with all the material that you've handed in to me. Please continue to do that. I'm very proud of you because of, it's a little bit different, but that's our growth mindset, that we're not fixed in the way we have to learn. We can learn in this way at that point. So I've been proud of you and your efforts that you've done up to this point. Let's keep it up and let's finish this out. Other than that, I have nothing else for you. Adios, you folks have a good day.